So let's do a review. All right, this is the one. Here it is. Okay, yes. Okay, let's start with 8A. Okay, so let's start with 8A first.
Okay.
Okay, so the formula to find the inverse of a matrix is this. So let's say if this is your matrix A. Okay, the formula to find your inverse matrix is 1 over your determinant A, and what you need to do is you switch place. So you switch place diagonally for your DNA, and then for your B and C position, you just add a negative sign over there. Okay, so this is the formula. Okay, this is the formula to find your inverse of A. Okay, so given this example, A is equal to this, A is equal to this. So first is to find your determinant A. Okay, the determinant A formula is AD minus your BC. Okay, so from this, AD is 2 times 5. Okay, minus, so your BC is minus 4, right? So 2 times 5 is 10, minus is plus 4. So your determinant A is 14. Okay, so with your determinant A equals to 14, so just continue here. So it's 1 over 14. And then what you do is your A and D, you switch place. Okay, and then the rest is your B and C, you just add a negative sign in front. So you get negative 4 here, and then you get plus 1 here. So I hope it's very simple. Okay, and then next is just get your 1 over 14 into each element. Okay. Okay, so yeah, this is the way to find the inverse of your A. Okay, given your A is this. Okay, so with this, so I will pass on to you to try just one of the question. Okay, so let me get this into the second page. Okay, so try out G. Okay, do it on a piece of paper. Try out G on a piece of paper. If you want to refer to this, you can also refer to this page. So try out G on your own on a piece of paper. Okay, I will pass it to you now.
Sure.
Okay, so G, question G. Okay, try it on a piece of paper. Okay, I go and grab water.
Okay.
Mm.
It's 1, -2, half, and 3, and 3 of 2.
Let me write it down first. So it's 1
1,
and
-2.
-2 for your B, and then continue.
And then half,
Mm-hmm.
3 of 2.
3/2.
Yeah.
Okay, good. Okay, so let's work it out together and see if let me check your answer. So at the same time, just go through together. Okay, so first thing first, what I'm going to do is I'm going to find out the determinant A first, right? So in this case, AD is 3 times 2 is 6 minus, so it's -4, so you get 10, right?
Yeah.
Good. So over here is 10, and then just change this 3, 4, -1 and 2. Okay, no, I need to switch place for this. So I get 2 and 3, and then I get -4 and +1. So you will end up with, am I right? How can you get 1? I thought you are supposed to get like 1/5.
Why?
Okay, so in the first place, do you agree that you should end up with this?
No,
So
it's a 1/10.
the determinant A is 10, right?
Yeah.
So if the determinant A is 10,
No, it's not 10.
oh, it's not 10. Okay, let me double check. Okay, so never mind. Let's double check again. So given this, so it's AD minus BC, right? So AD is 3 times 2, so it's 6, right? Minus, so 4 times -1 is -4, right? So is it 10?
Okay, yeah.
Yeah, so it's 10, right? Okay. So once you get 10, so what you do here after this step is 1/10 times 2 is 1/5. So similarly, so just okay, so this is your next element, and then this is your so subsequently. Okay, good. All right.
Okay.
Okay, so yeah, so we can move on. So it's important to get the correct this determinant A. Okay, and then you just times in to each element. Okay, so yeah, so let's move forward. Okay, question 8. Okay. So the question here says find if it exists. You know what I mean? So that means sometimes, let's say if you have your A, and sometimes your A inverse does not exist. Okay. Okay. So given the structure, A inverse is equal to this, right? Right.
Yeah.
So can I ask you at what condition? At what condition your this A inverse does not exist?
I don't know.
When your when your determinant A is equal to 0, then your A inverse does not exist because 1 over determinant A is 1 over 0. So 1 over 0 is not valid, right?
Yeah.
Yeah. So sometimes you might not get your A inverse. Okay. When it happens is when your this determinant A is equal to 0. So when your determinant A is equal to 0, 1 over determinant A is equal to 1 over 0. And this makes your this not valid. Okay. So this is the condition. Okay. This is the condition where your this A inverse does not exist. Okay? All right?
Yeah.
So let's move on. Solving a pair of linear equations. Okay, so let's continue. So this is the continuation from our matrix. Okay, chapter matrix. So over here, you have two lines. They intersect with each other. So this is the solution. Okay, you have one solution because they intersect at one point. So over here, there is no solution because these two lines are parallel to each other. Okay, and then there is the third possibility where these two lines they coincide with each other. Okay, so when they coincide with each other, so you have infinitely many solutions. Okay, so
Okay.
let's move on. So remember, case one is they intersect at one point. Then over
Yeah.
here is they are parallel to each other, so they never intersect at all. Over here is they coincide with each other, so there are infinitely many solutions. Okay, so let's
Yeah.
move on. Okay, so the example 10 here is say if A is this, and then you need to find your determinant A. Okay, so determinant A, you just proceed with the formula AD minus your BC, and you figure out your determinant A is 5, given A is this. Okay, now, so that means what? That means why we want to learn how to find our A inverse. Okay, what's the application of our A inverse? Okay, so now I'm going to show you why we want to find our A inverse. Okay, so this is your A, and if you times your A with your A inverse, what are you going to get?
0.
Let's say you have
Zero.
your 8, you times your 1 over 8, what do you get?
1.
1. So for this algebra, this is in algebra, okay, you will get 1, right? So for this one is matrix. Okay, so for matrix, you will get an identity matrix. Okay, so if you have your matrix A times the inverse of A, you will get your identity matrix. Okay, so similarly, algebra, you will get 1. So therefore, let's say you have this. Let me get the question from here to the slide. So if we have our A 2, 3, 1, 4, so this is our A. So the determinant A is given by this. Okay, so it's a 5. So what we can do is our A inverse 1. I mean our A inverse, it exists because this is valid. So first I switch place A and D, and then I add a minus sign to my B and C. And if I continue, I will get this 4 over 5. Okay, minus 1 over 5, minus 3 over 5, and 2 over 5. This will be my A inverse, right? Okay, now, then let's go ahead and figure out this part. So it says, does this have a unique solution? Okay, does this have a unique solution? So the answer is yes. Why? Because your this determinant A is not 0, right? So here it shows your this A inverse exists. Okay, it exists because your this determinant A is not 0. Okay, so when it exists, so there is one solution. Okay.
Yeah.
Okay, so there is a solution. Okay, so In fact, we can make use of our this inverse A to find out our answer above here. So now I'm going to demonstrate to you. Okay, so let me erase some of the stuff here so that I can show you. So let me erase this. So this is our inverse of A, and this is our A. So now, let me get this. This is my inverse A. Okay, so now you have these simultaneous equations.
Yeah.
Okay, we have a few ways to solve our simultaneous equations. So now I'm going to use matrix to solve this simultaneous equation. So the left-hand side here, LHS, you can actually express it in matrix form. Okay, you will get this. Okay, and then you should see that your this entire simultaneous equation, right? Your this entire simultaneous equation, you can actually represent. You can actually represent it in matrix form. You actually represent it in matrix form. How? So you actually represent it this way. Okay, so the left hand side, you can actually represent it by this. So the right hand side is this. Okay, so the first thing you need to do is, this is your simultaneous equation. Okay, and then you need to transform it into a matrix format, and then after that you just solve your this matrix accordingly. Okay.
Yeah.
Okay, so let's look at how we can solve our matrix here. So now we need to find out how can we solve this matrix. Okay, how can we solve this matrix above? Okay, to solve the matrix above, so let me erase this. So I also erase this. Okay, so can you see that this is your A and this is your X and Y? Actually, I don't need a bracket. Right? I don't need a bracket here because it's represented by A here already. So can I ask, now what you need to find is, you want to find out what is your this X and what is your Y here, right? That's what you need to find out, right?
Right.
So in order to find out your X and Y, so that means if you can get rid of your A here, so this is your left hand side. If you can get rid of your left hand side, it's actually your matrix A times your bracket X and Y. But your objective is to find out X and Y. So it means your objective is to get rid of the A here. So how can you get rid of the A here? You can times your inverse A to it, right? So when you times your inverse A to it, this A, ultimately you will get rid of your A, right? Because your A -1 times your A, so you will get rid of these two things. Basically, you can get rid of it.
Right.
Am I right?
Yeah.
Yeah. So that's the idea behind why you need to learn how to find the A inverse. Okay. Once you have found the A inverse, what you need to do is you can actually times your A inverse to the left hand side. So you times your A inverse to the left hand side. That will help you get rid of your A here. So you can get rid of your A here. So your left hand side will be left with x and y. And that's what you want. That's what you want. Okay? So if your left-hand side, you already times your a negative 1, a inverse. So you also need to times the right-hand side with a inverse, so that this equation is balanced. Am I right? Okay? You need to balance it, right? Am I right? Hello?
I don't understand. I don't understand.
Okay, don't worry. Let me get it to the next page, so it makes things easier. Okay, so this is your matrix form, and this is your matrix form of the simultaneous equation. This is your A, this is your x and y, and then this is the right hand side. Am I right? So the objective is to find out your x and y, right? That's your objective, right? This is what you want to find out. This is your objective. This should be the last step, right? Am I right? So your job is to find out what is your this space and what is this space. If you can find it out, then that means you have already found out your x and y. Am I right to say so?
Yeah.
So that means clearly your left hand side, you just want the left hand side to be left with x and y. Am I right? So in order to do that, you need to times the a inverse to the right hand side, the left hand side. Because once you times your a inverse to the left hand side here, you will get rid of your a, right? So you will get your this x and y on the left. Make sense?
Yeah.
Does it make sense? So if you times, so this is what you times to the left hand side. So once you times the a inverse to the left hand side, you are supposed to times the a inverse to the right hand side as well to balance your equation. Am I right? So you have added a a minus to the left hand side. You also need to add a minus to the right hand side to balance, to make this valid. Am I right?
Yeah.
Yeah. So once you have added in this, a minus 1 to the left hand side, and you have added in this a minus 1 to the right hand side, so you are left with what? You are left with this on the left hand side, because these two cancel each other. These two cancel each other. Am I right? So your right hand side will be given by this one, right?
Yeah.
Yeah. So your A inverse one is, so I need to refer to the previous page. Your A inverse one is this. So let me just get it over here. So this is your A inverse one.
Yeah, that's the A inverse.
Okay. So this is your A inverse one. So what you need to do right now is you need to solve your right hand side now. Over here. Now your job is to find out what is this right hand side. Am I right? So let's continue to do it. Okay. You have a what? So this is a 2 by 1. Okay. And this is a 2 by 2. So you can see that they can't give you a valid multiplication, right? Am I right? If you take this, they cannot give you a valid multiplication. The reason is you have a 1 and you have a 2 here. So this, they don't match. So you cannot have a valid multiplication. Am I right or not?
Yeah.
So what you do? Switch place. Okay, switch place. So instead of 2, so 2 by 2 times your 2 by 1. So now it makes it valid, right? It makes the multiplication valid, right? So what you do is you just switch place. So basically you just take this to the front. Okay. So basically this, you just take it to the front and then take this whole thing, 4 and minus 1 to the back. Okay. So you just solve this. Okay. How do you solve? So you do this. Am I right? So this will give you this answer, right? This will give you this answer, right? So 4 over 5 times 4 is 16 over 5. Okay. Minus 1 over 5 times minus 1 is 1 over 5. So plus 1 over 5. So you end up with 17 over 5. Okay. Before I simplify, so you should get 17 over 5. Okay.
Yeah.
Next, you do for the below term, this term, and this. So you will get minus, so 1 over 3, minus 3 over 5 times 4 is minus 12 over 5. Okay. Plus 2/5 times negative 1, so it's negative 2/5. So this will give you negative 14 over 5. Am I right? So now you can continue to simplify it. And you will get 3 and 2 over 2, 2 over 5. And then over here is 2, a negative 2, 4 over 5. So your x is actually equal to your this, and then your y is this. Okay? Okay. So if you want to use matrix to solve simultaneous equation, this is the way you can solve matrix using, this is the way you can solve simultaneous equation using matrix. Okay? It's more complicated than the usual elimination method or substitution method. Okay? So is there anything you don't understand here? Hello? Is there anything you don't understand here? Hi, Michael.
Yeah, I don't understand. I don't.
Okay, then let's go for a very simple question. Okay, let's do the usual way first. Let's say we have x plus y equals to 2. Okay, maybe 3. Make it easier. Then we have 2x plus y. Okay, 4. Okay, so for this question, right? For this question, your x is equal to 1 and y is equal to 2. Okay, for this question. Okay, so let's make use of matrix to solve instead. So this is your simultaneous equation. Convert it into matrix format. So the matrix format will be this. Okay, so far so good. So far so good.
Yeah.
So this is matrix format. Okay, so if this is the matrix format, so your objective is to, this is your objective. Do you agree? Because ultimately you want to find out what is your X and what is your Y, right?
Yeah.
So this is your objective. So that means your objective is your left hand side should only have X and Y. So, but now your left hand side have this and this. So your objective is to have X and Y. So what you need to do to your left hand side?
So I don't know. What?
Your objective is this, right? The final step. Am I right? Is this your objective? The final step?
Yeah.
Yeah. So your objective is to have X and Y on the left hand side here. Okay. But now your left hand side have this and this. So how do you end up with just this? How? You need to think of a way to get rid of this, right? Am I right?
What?
Oh, okay. So if this is slightly hard, so let's start with this then first. Okay. How do you get X? How do you get X in this case on the left hand side? You divide by 2, right? I mean, you need to get rid of the 2 here, right? In order to get X. Isn't it you need to get rid of the 2? Hmm?
Wait, what?
Okay. So how do you do this question? 2x equals to 4. How? How do you do this question? 2x equals to 4.
Use x equals to 2.
Yeah. How do you get x equals to 2? How?
4 divided by 2.
Why do you need to take 4 divided by 2? Why?
Because x equals to 2.
Okay. So that means we have been doing it without knowing why we do it or how we do it. Okay. So in fact, right, the step you jump from here to here is what you do is you are actually doing this without you realizing it. You are actually doing this. Okay. You are doing divide by 2 on the left hand side and you are doing divide by 2 on the right hand side. Okay. That is the step. We are so used to it without even realizing this. Okay. So when you have divide by 2 here, 2x divided by 2, you end up with x. Because 2 divided by 2, you cancel. Am I right?
Yeah.
Yeah. And then 4 divided by 2, you get 2. But normally we don't do this step because we are so used to it. Okay. But in fact, that's what you have been doing. Okay. You have been dividing by 2 on the left hand side and dividing by 2 on the right hand side to reach this. Okay. Without us realizing. Okay. So similarly, let me give you another example. Okay. So half x is equal to 2. Okay. How do we get x equal to something? Okay. What we have been doing is half x. How do we get rid of the one half here? We are actually doing times 2 and times 2 here. Okay. So once you times 2, you will realize this half, you times 2, you will get rid of this 2. You will get rid of it. That's why you left with x. And then over here, you get 4. Okay? That's what you have been doing without you realizing it. Okay? So far, so good?
Yeah.
Yeah. So similarly, Now, what do you have? You have this term here, right? Times this term, right? Here is times, times. So now, your objective is just to have this x and y. So what you need to do is, how do you get rid of this? Right? So you get rid of it by divide this term. Right?
Okay.
Am I right? But when you divide by this term, is it, so let's call this, okay, let me use a letter to make things simpler. So how do you get rid of your A? You are actually dividing A, right? Okay, but doing matrix, we don't have divide. So we have only learned what? Times. So what you do is, to get rid of my A, I need to times A inverse.
Okay.
Yeah, that's what I mean. So that means you need to A inverse both sides. Because you have introduced an A inverse here, so you also need to introduce an A inverse on the right, so that you can balance. This equation is still balanced. Okay? Okay? So do you know why I introduced an A minus here? Here. Why I need to introduce an A minus here? Because these two can be eliminated.
Yeah, I think so, yeah.
So that I can get, because your objective is this. Okay? So that's why I introduce an A minus 1. So when you introduce an A minus 1 to the left hand side, okay, this one is what you introduce. So you also need to introduce an A minus 1 to the right to balance the equation. Okay? To balance the equation. Okay? So similar to this. Okay? Similar to this. If you have introduced a times 2, you also need to times 2 here. Am I right?
Yeah. Yeah.
Same concept. Okay, same concept. So once you have introduced this A minus 1 here, that's why you can get rid of this 2. That's why you can get this. So basically, you have reached your objective.
Okay.
Okay. So once you have reached your objective, now what you are left to do for the right hand side is this. Solving this.
Okay.
Solving this. Right?
Okay.
So that's why you need to learn how to get your A inverse 1. Okay? So we have already found our A inverse 1. So let me refer to the previous page. Our A inverse 1 is this. Okay, this is our A inverse 1. Then I just need to solve this. Right? Okay, so this is your 2 by 2. This is your 2 by 1. So it's valid, right? It's valid, right? I hope you can see that this multiplication is valid, because so what you need to do is just solve it accordingly. So you end up with a 2 by 1. Okay, so free up these 2 blank. Okay, how do you get the first blank? You do this, right? So you get 4 over 5 times 3 plus negative 1 over 5 times 4. Okay, so what do you get? So you get your 3 times 4, 12, minus 4 over 5, right? So you get 8 over 5, right? And then similarly, right? Oh, by the way, yeah, by the way, the A minus 1 is not, I just realized this is a different question. Okay, your A minus 1 we have to figure out ourselves. This is not our A minus 1. This A minus 1 is from this A minus 1 is our previous question. So I took the wrong I took the wrong A minus 1. I still need to figure out what is my A minus 1 here first. Okay. So I need to figure out what is my A minus 1. Okay. My A minus 1 is I need to figure out here. Okay. So my A is actually equals to this 1121. 1121. Okay. So first I need to figure out my determinant A first. Okay. Then this one switch place. This one is -1, -2. Okay. So to figure out my discriminant A, AD is 1. And then BC is this -2. So it's -1. Okay. So therefore, this, yeah, I can quickly figure out my A inverse. So A inverse is this. So it's this 1, 2, 1. So this is my A inverse. Okay. So once you have an A inverse, so you just get it here. Okay. So now you can figure out your this. So you just need to fill up this and this. Okay. How do you get it? This will give you the first element. So -1 times 3 is -3 plus 4. So this will give you 1, right? Similarly, for this element, you get 2 times 3, 6 plus -4. Yeah, so the answer is 1 and 2. So can you see? The answer and this answer is the same, right? Am I right?
Yeah.
Yeah. Of course, you realize using matrix method to solve simultaneous equation is so tedious. Okay. That's not the point here. The point here is we want to use matrix to solve simultaneous equation. Of course, given a choice, I would not prefer matrix to solve simultaneous equations. Given a choice, right? But if we are asked to use matrix to solve, this is the method. Okay. All right.
All right. Yeah.
Yep. So, is there any question on this slide? So you have any question on this slide? Like, any question on this slide?
No.
No. Okay, good. So, yeah, very good. So the concept is pretty simple. You just times A inverse on both sides, and then you continue to solve accordingly. Okay, very simple. Okay, we can take a break, come back,
Okay.
then we'll continue to practice. Okay.
Okay.
Okay, good. So I will mute my video and audio first. Okay, I'm back. If you're back, just let me know.
Oh,
Hey, welcome back. Okay, can you hear me?
yeah, I can hear you.
Okay, very good. Okay, we were talking about how to. I'm sorry. Okay, we were talking about how to use a matrix to solve simultaneous equations. So yeah, so let's do one question. So to have a better understanding of the matrix way of solving simultaneous equations. Okay. Let's start off with this one. So let's start off with this one. Okay, so let's do step by step first. So first, can you find out what's the inverse of A first for this question?
Inverse of
So first find out what's your A, and then find out your inverse of A.
yeah. Okay, A is what? It's 3, -1, 2, 3.
Nice. 3, -1, 2, 3. Very good. So yep, continue to find out what's your A inverse. So just writing down the formula for you. So hope it helps.
1 of 11. It's 1 of 11, 3, 1, -2, 3.
Okay, so your determinant A is AD minus BC. AD is 9 minus, so it's 11. Very good. So you get 1 over 11. 3 and 3. When you switch place, it's still the same. And then 1 and... So you're supposed to get this, right? Am I right?
Yeah.
Very good. So next is solve it. Okay, solve this using the matrix way. Yeah. So how do you solve it the matrix way? So this is the final step. A inverse 1 times your 8 and 6. So your job is to figure out this. Okay, try it out.
Okay. Okay, equals 24, 6, -16, 18, all over 11.
Okay, so let's do it together and you check my answer against yours. Okay, so what you do is, so you start with this, and okay, by the way, let me share with you, you can also, before you times this 1 over 11 into it, right? So what you can actually do is, you can do this first. Say, okay, I don't need a bracket. So yeah, so let's work it out together. Okay, what I'm going to do is, I can actually do this first. Okay, the reason is because it's times, so I can actually do the back first. Okay, so what you get after this is, you're going to get this, right? Okay, this will give you your first element. Okay, which is here. So 3, 8 is 24. 24 times your 6 is 30, right? Okay, next is second element, which is this times this. Negative 16. So negative 16 plus 9. So you're supposed to get negative 7. Am I right? So then now you times it into it. You times your 1 over 11 into it. So you're supposed to get this. Do you get this?
No,
Okay. So which one is different from you?
I just times 11, divided by 11 into the A. Just simplify the A11.
You mean you are going to simplify it further like this?
No, I mean like
Uh-huh.
I just did the A inverse times the 8 and 6.
Yeah, sure. But I thought our answer should be similar, right? Here, right? Should be here, right?
Okay, let me see. It's 30 over 11 and
Yep.
then 2 over 11.
2 over 11. That means this answer is different. The second element is different. That means this is different between the two of us, right? So let's look at it again. So you have your minus 2 times 8 plus 3 times 6 minus 16 plus 18. Oh, you're right. Okay, so this is supposed to give you 2. Okay, thank you. So it's hard without using a calculator. So please use a calculator. Okay, so yep, it's supposed to be 2 over 11. Okay, so please use a calculator. Okay, actually, to just make this, because this is a improper fraction, so it's good to express it in a proper fraction. Okay, for your final answer. Okay, all right.
Okay.
Yeah. So, one I just want to share this with you. Like, instead of times your 1 over 11 into this first, I can actually do this 2 first. Okay, so I can get the answer faster. You realize that? Okay, that means leave your 1 over 11 at last. Okay, you can actually speed up a lot because you want to play with whole numbers instead of fractions. Okay, so but it's up to you. So if you want to speed up, do the whole numbers here first, these 2 first, before you times in your 1 over 11. Okay,
Okay.
any question on this slide? If not, we move on.
Okay, move on. Yeah.
Yeah, thanks. Okay, so that means now you have grasped the concept of solving simultaneous equation using the matrix method. Okay, let's move ahead. Okay, let's look at question 6. Okay, it's a huge question here. Let me get it out. Okay, so it says consider a system which is this, and write the equation in the form ax equal to b, and find your this okay, this a part 1 is really simple. What you do is you change your this simultaneous equation into a matrix format, which is this. Right? Okay, so this is converted to matrix format. And this will be your A, and this will be your X, and this will be your B, similarly. Okay, so now you need to find out this. Okay, determinant A is very simple, AD minus BC. Okay, AD is minus 2 minus 12. So you get minus 2 plus 12 is 10. Okay, so determinant A is 10. Okay, does the system have a unique solution? Yes. Okay, because your determinant A can be found, right? So you can actually move ahead to find your A inverse. Okay, switch your AD and then add a negative sign to the B and C. This should be your A inverse. So like I say, I will leave the 1 over 10 at last. Okay, so now what I need to do is your X and Y is equal to A inverse, which is 1 over 10 times your this 8 and 7, 8 and 11. Okay, so you get your this first element by doing this. Okay, minus 8 and 22. Minus 8 and 22. Minus 8 plus 22 should give you 14. That's your first element. And then your second element is minus 32 plus 33. That will give you 1. So then now you times in your 10, so you're supposed to get this. Okay, so this is the answer for 6A part 2. Okay, pretty easy. Okay, now part B, so it says this is another system and K is not known. Okay, can you see K is not known? So I hope you can see, let me get this to another slide. Okay, the difference between these two questions is here. Over here is minus 3, okay? Over here is plus K. So what you do is get rid of your minus 3, replace it with K, right?
Yeah.
And then, therefore your A is different already. I mean your determinant A is different already. So let me just get rid of all this. So still 8D minus BC. AD is minus 2, then minus 4K. You're supposed to get minus 2 minus 4K. Okay, that's your determinant A. All right. For what values of K does the system have a unique solution? So in order for this question to have a unique solution, your this cannot be equals to 0, right? So therefore, your this has to be not equals to 0. Am I right?
Yeah.
Yeah. So if you continue, so you take out so move it over, then half, right? Minus half, yeah. So K cannot be minus half. Okay. All right. So this is the answer for this part 2. Okay. Okay. Find K when the system does not have a unique solution. How many solutions does it have in this case? So for what values of K does the system have a unique solution? Find the unique solution. For what values of K does the system have a unique solution? So to have a unique solution, okay, So if your k, that means if your this is equal to 0, so what it means is you don't have any solution. Okay, no solution. Okay, so now they want to know for what value or values of k does the system have a unique solution. So find this unique solution. Okay, so find this unique solution. So how do you solve this question? Then,
I have no idea.
so there have some examples here. So the system is this, and then since it's not equals to 0, so exists, so there is a unique solution. Okay, so as long as your this a minus 1 exists, then there is a unique solution. Okay, similarly for this question, so once you have this is how you can use matrix to solve simultaneous equations. Okay, so this one we don't need to take a look at. So this is the one. This is the one. So k is not known, like the question just now. K is not known. So find a minus 1. Okay. Similarly, this is what we have, right?
No.
Yeah. So similarly, you will find out that your this 2k plus 4 cannot be 0. So similar to our question. Okay. Let's park it side by side. So over here it says 2k plus 4 cannot be 0. Okay. Our side here is minus 2 minus 4k cannot be 0. Okay. So which is when k cannot be minus 2 for this question. Then for this question is k cannot be minus half. Okay, so state the values of k for which this inverse exists. So the inverse exists if it's not equal to this. Okay, so then we can start to solve this. So for what values of k does the system have a unique solution? So as long as it's not equal to this, it will have unique solution. So find the unique solution. Okay, then we have to continue to solve it. Okay, so to continue to solve it, I need to find my A inverse. Yes. So A inverse is equal to A over this one, and switch place A and B, which is here, minus 1 and 2, and then add a minus K and add a minus sign to your B and C. So this is your A inverse. Okay, I'm going to get it out to the next slide. So your A inverse is this, and over here you have this. You have this. Then over here you have this. Okay, so minus 1 here, minus k here, minus 4. Okay, good. Okay, so this is the one. Okay, of course you can go ahead and simplify, because you actually simplify this. Not simplify, but factorize. You take out your minus 2, you will get 1 plus 2k. Yes, you'll get this. Okay, so if you want to simplify it further, so you what you get is so instead of this, okay, so you get the first term here, you will get this. Okay, so you actually get rid of the minus sign. Okay, that's your first term. And then the second term, you can get rid of the negative sign also. So you are left with k. Okay. And then So for this term, -4 and -2, you are left with 2 above. Simply this. And then for this 2 and -2, you are left with negative sign. So it's, yeah. Okay. So this is your simplified version. So far so good?
Right.
Yeah. So by the way, both are acceptable. But if you want to simplify it further, then you can actually simplify it a bit, tidy up a bit. Okay. Now, what you do is, so this is my A inverse. So let me get this out. I need the A inverse to solve my question. So the question is this. So it's 8 and 11, right? Can you see? 8 and 11, I need to times 8 and 11. So A inverse times 8 and 11. Okay. So just this. So what you get is this times this. You get, okay, the first term is this. Okay. And then this times 11. So you get plus, right? Okay. And then the second term is this times this. The first term will give me this plus. So minus 11, 1 plus 2k. Okay. So you can actually simplify above, which is 11k plus 8, and then you have 2, 1 plus 2k. And similarly below is plus 5. Okay. Yep. Okay. So this is the question. Okay. So this is the unique solution. Okay. In terms of k. And remember, k cannot be negative half. All right.
Yeah.
Yeah. So this is the way to solve it. Okay. So does not have a unique solution. So basically, you just this value k equals to negative half will not have a unique solution. Okay. So this is a part two answer. This is part 2. Okay. And then part 3 is k is equal to negative half, because this will invalidate the A inverse. Okay. So that's why that's why this is your answer. So you will not have a solution. Okay. So
Okay.
pretty easy. Okay. Further matrix algebra. Okay. What it says here is a squared is equal to 2a plus 3i. This is the identity matrix, and find A inverse in the linear form, something like this. So let's see. So a squared is this. So basically you times your a. Let me get this out to explain this. Okay. So this is the question. Okay. And then the second step here is you times A inverse on both sides, so that you get rid of your this. Can you see you can get rid of this? So you only get A, right? Right? For the left hand side. Right? So after that, for the right hand side, you can see that you can open the bracket. Okay, you open the bracket, you get this. And then you open the bracket, you get this. And A minus 1 and A, you get rid of this. And you get rid of this. Right?
Yeah.
So, so this is what you get. So you will end up with this. I'm doing this step. 2 plus 3 a to the power of -1. And then what you do next is you just move the 2 over to the move this 2 over to the left hand side. So you end up with this, right? Right? So your A inverse 1 is you divide by 3, right? Get rid of the 3. So divide by 3 here. All right. So if you write it properly, so you will get A over 3 minus 2I over 3. Okay. Basically, you split these two terms. You split this term into these two terms. Okay. I hope you see this, like A minus B over 3, right, is equal to A divided by 3 minus B divided by 3. Okay, so I'm actually using this one to get from here to here. I'm using this. Okay, so this is what they are talking about. Okay, so therefore, if you open open the brackets here, okay, you end up with this, and this is in the form of RA plus SI, right? Okay, this is the form RA plus SI. Okay, your value of S is 2/3, okay, and 1/3 is your R. Okay, oh, your S is actually minus 2/3. I'm sorry. Okay, the minus sign is included. Okay, so with this, so let me demo a question. Let's start off with the first question. Start with the first question. Okay, you have your this, right? So you have your AX B equals to C. They say you need to find X here, right? Right?
Yeah.
How do you find X? To find X, right? What you do is you can actually times A minus 1 on both sides first. Because once you times A minus 1 on both sides, you can get rid of this. So you're only left with your XB. Okay? So let me figure out what's my A minus 1 first. So A minus 1 is equal to 1 over A determinant. Then switch place, which is 1 and 2. Then add a minus sign. Okay, so determinant A is AD minus BC. AD is 2 minus 0 is 2. So it's 1 over 2. 1, 0 minus 1, 2. Okay, so this is my A inverse. So get it here times my C, which is given by this. Okay, so before I times my half into this, I will do this first. I will do this 2 first. Okay, so I get half. Okay, 1 times 0. Oh, hold on. You have a 2 by 2 times 2 by 2. So you will end up with a 2 by 2. Right? So to do this, what you do is focus this one first. 1 times 0, 0. So it's minus 1 times 1. So it's minus 1. Okay. Next, this and this. 1 times 3 is 3, then plus minus 2, so it's 3 minus 2 is 1. Okay, 0 and 0 plus 2, so it's 2. 0 times 3 is 0, this is 4. So the question is pretty simple. 0.5, 5, and then this is 1, this is 2. Okay, this is your XP.
Okay.
Okay, then now what to do? So you have XP is equal to this. So how do you find your X now? How do you find your X?
Times inverse of B.
Yes. Right? So whatever you have here, okay, because these two will get rid of each other. So what you need to do is you just need to do your right hand side. Of course, before you can do your right hand side, you need to figure out what's your B inverse first, right? Okay, so it's not very difficult, but it's very, very tedious. Okay, a lot of steps. Okay, so you just have to be patient and then do it accordingly. Okay, not difficult, but very, very tedious. Okay, so this is your what 11C part 3. Wow, can you see they have 3 times 3 matrix?
Apparently.
Crazy stuff. You just look at the 3 times 3 matrix here. To find the determinant of a 3 times 3 matrix, so this is the formula. Okay, this is the formula. I will say it's just more work. Okay, it's just more work. Okay, it's just more work. So much work. There is a lot of work to do. Okay, but I really don't know. I really don't know why they want to test you the 3 times 3 matrix, because all this can be done by a calculator, and I don't know why they want to test you like up to 3 times 3. It basically doesn't make sense to me. Okay, if you look at this, okay, your determinant A is given by this. Okay, and this is your A. Okay, this is your B. You see, it's minus B here. This is your C. This is plus. And then you need to group your this E, F, H, K. Can you see your E, F, H, K? Okay, and then your D, F, G, K. You know D, F, G, K. Okay, and then what? D, E, G, H. D, E, G, H. So I hope the formula is given. Okay. So that's all you need to do. So if you follow, you get -9 for the determinant A, 3 times 3 matrix. Okay. Nothing much. Okay, but a lot of work. Okay. If you can use your calculator, right? Don't use. Go ahead and use your calculator. Okay. Just write this step, and then you don't have to do this. All right.
Okay.
Then you just use your calculator, you get your -9. Save a lot of trouble. Okay. I don't think anyone want to go through all this trouble finding this, because it takes a lot of work. Doesn't make sense to do all this during the exam. You don't have enough time, right? That's why you see, you are encouraged to use a calculator, okay, to solve this one. Okay, so let me go further. Solving systems of linear. Okay, so it's the 3 by 3 matrix to solve these 3 equations, 3 unknowns. Okay, let's continue. So that's the the max you will get is 3 times 3 matrix. Okay?
Okay.
Yeah. Okay, so what we have learned so far for matrix is, um, let me give you a summary of what we have learned so far, right, of matrix. So number one, we learn how to use addition and subtraction of matrix. Okay. Next, multiplication, okay, and inverse. Okay. This one is actually for us to solve our simultaneous equation. Okay. This is for us to solve our simultaneous equation. Of course, the hardest they can test you is 3 times 3 matrix. Okay, but I don't think it makes sense during the exam. Okay, it doesn't make sense during the exam. You might not have enough time to do it manually during the exam. So you are encouraged to use technology to solve it. Technology
Okay.
to solve this 3 by 3 matrix. Okay, because it's a lot of work just to do the 3 by 3 matrix. Okay, so yep. So do you have other questions on matrix?
No.
Okay, then if not, then we can actually call it a day for
Okay.
this lesson.
All right.
Okay. Also, what have you been doing?
Not much.
Not much. Have you watched the Bundesliga or the upcoming La Liga?
Yeah, I'm watching Bundesliga. It's not very interesting.
Oh, okay. Yeah, without the fans, and then without the fans is kind of like weird, right?
Yeah,
Without the
it's
without the
super weird.
cheers and all. Is there commentator, by the way?
There are commentators.
Oh, okay, okay. Because I have not watched any of them, and even these days it's very hard to watch it on live also. I don't know where to watch it live, so yeah. Let me
Okay.
save you on this. Okay, so if not, then we can end it. End the meeting, and see you again. Thank you.
Okay. See you.